Today we will solve the problem 2.47 of Griffith 4th edition Introduction to Electrodynamics. The problem 2.47 is find the net force that the southern hemisphere of a uniformly charged solid sphere exert on the northern hemisphere. Express your answer in terms of the radius capital R and total charge capital Q. Here the problem is we have a we have a sphere which is uniformly charged. In previous case, in problem 2.42, we have only surface charge, that is at the surface you have charge. In this case, you have volume charge because the charge is uniformly distributed, and we have separated this sphere into two parts, northern hemisphere and southern hemisphere. According to Gauss law, the total electric field, that is closed integral of electric field dot the area is equal to small area under consideration Gaussian surface is equal to the Q charge enclosed by the Gaussian surface divided by epsilon naught. So here TA is equal to, we know TA is equal to 4 pi r square. So I have replaced, if you integrate TA, you will get 4 pi r square, and charge n, which is equal to charge enclosed over epsilon naught. So the charge enclosed under the area under consideration is the uh, uh, volume charge density, that is rho, multiplied by the volume, that is volume enclosed by this small r. Here you have r uh, which is less than capital R, that is inside the sphere. Charge enclosed is equal to rho 4 by 3 pi r cube. So now you substitute this here. You will get that is electric field inside the sphere multiplied by 4 pi r squared is equal to the charge enclosed, that is rho 4 by 3 pi r cube, and you have epsilon naught here, 1 over epsilon naught. Now you cancel out the common term both side. You have 4 pi r squared. Here you will have 4 pi r cube. So this will become simply r. Electric field inside the sphere is equal to this rho multiplied by r over 3 epsilon naught r cat. We are considering along this direction r cat. So unit vector along this direction is r cat. This is r, and this is z axis. And the unit vector along z axis is naturally z cat. Now you know if we have to find this force per unit volume. Force per unit volume is equal to generally formula from the Lorentz force, F is equal to Q multiplied by electric field. So here force per unit volume, F of z along z direction, you remember that along z direction, is equal to charge per unit volume multiplied by the electric field inside the sphere. So we know electric field inside the sphere, and here you have rho r over 3 epsilon naught. Rho multiplied by rho is equal to rho squared. Rho squared, so this will become F F sub z over a volume is equal to rho multiplied by E sub in, so which is equal to rho r over 3 epsilon naught. Already here you have one rho, so this will become rho squared r over 3 epsilon naught along r cat. So this cos theta, this angle is theta. So naturally it is z cat unit vector divided by r cat is equal to cos theta. Z cat divided by r cat unit vector, both are unit vector, is equal to cos theta. So now you use cos theta, which is a z cat r cat. So this r cat will get cancelled. You will get z cat. Force per unit volume along z direction is equal to rho square r over 3 epsilon naught cos theta z cat along the z direction. We will further simplify this. So the force per unit volume along z direction is equal to rho square r over 3 epsilon naught cos theta z cat along z direction. So here you can take rho squared over 3 epsilon naught outside because it's a constant. Then you will have r cos theta t tau. That is, we are integrating over a small volume t tau along z direction. You know very well this theta in cylindrical spherical coordinate is this one. So that is r squared sine squared theta t theta t pi t r. So if you integrate this t pi between 0 to 2 pi is you will get 2 pi. I am bringing that 2 pi outside. So this triple integral will become double integral because we have carried out the integral with respect to pi, which is 2 pi. Then you can, rho is equal to charge per unit volume. Charge is q and per volume 4 by 3 pi r cube, capital R cube here. So this 3 will go to numerators and then this can be written as 3q over 4 pi capital R cube. So if you square it, here you have rho squared, square it, you will get 9q squared divided by 16 pi squared r power 6. Just I am squaring this. Now we can cancel some of the term. That is, before that we will solve this thing. So we can cancel this 2 pi with this 16 pi square. So you will get 8 pi. You remember that. Now we have to integrate. Remember that this theta term, you have cos theta, sin theta, cos theta, sin theta, d theta. We are not integrating between 0 to pi because we are taking in hemisphere, not full sphere. Full sphere means this integral limit is 0 to 5. We are taking only hemisphere, so this will be 0 to pi by 2. You have cos theta, sin theta, d theta. And next r, here you have r, here r squared, so you will get r cube dr. This is limit between 0 to capital R. Now what is this integral value? If you, after applying limit, you will get r power 4 over 4. If you apply the limit 0 to r, then only upper limit you have r power 4. That is r power 4 divided by 4. Then here cos theta sin theta can be written as 1 over 2 sin 2 theta. This is 1 over 2 sin 2 theta. This is equal to this one. 1 over 2 sin 2 theta t theta. Now you can cancel some of the term. If you multiply 4 into 8, you will get 32, and you can cancel this r power 4 with this r power 6, which will become just r square. So we have taken 32, because 8 into 4, 32 pi. Here you have pi into r square. You have this r square. Now you have to carry out the theta integral. That is between limit 0 to pi by 2 of sine 2 theta t theta. So now we will carry out the last integral. Now we got the force along the z direction is equal to 3 pi epsilon naught q squared over 32 pi r squared integral between 0 to pi by 2 of sine theta. Now you bring this 2 outside. So this will become 64. 32 into 2, 64. Then integral is between pi sine theta, sine 2 theta. If you integrate sine 2 theta with respect to theta, then you will get minus cos 2 theta, and this 2 theta, if you integrate again, you will get 1 over 2. So minus of cos 2 theta. Now you substitute this limit 0 to pi by 2. 0 to pi by 2. This is pi by 2. So before that, then you have minus of. You take minus of outside. Then this will become cos 2 theta. Upper limit cos 2 theta means cos pi. Minus lower limit is cos 0. So this will become minus of cos pi is minus 1, and cos 0 is 1. So 1 minus 1. This is minus 2. So minus of multiplied by minus 2. Minus of minus will become plus. Then this 2 will cancel out. The value of this will be, after applying the limit, is just simply 1. So now you got the force along the z direction is 3q squared over 64 pi. You have pi and the epsilon naught r squared. Now you bring this. This 16 can be written as 64 can be written as 16 multiplied by 4. So I can separate this as 1 over 4 pi epsilon naught. 4 pi epsilon naught. The remaining thing is you have 16. In the numerator you have 3q squared over this 16 r squared. So this is the final answer as given in the problem. Thank you very much for watching my video and supporting me continuously. Thank you very much.